All right, so I thought I'd get out of the maker space in the basement for a little bit and enjoy this beautiful day. One of the benefits of being stuck at home, or stuck working at home, I should say. Um, so, we're going to give you a little design challenge today. I want to show you what the actual issue is first, and then we'll talk about how we can follow the engineering design process in order to solve it. So, check it out. Where are you coming from?
Home to work.
So after watching that, you're probably thinking, well, there are a number of problems here. First and foremost is there's a 3-year-old driving, right? That's probably the biggest problem. So that's clearly easy solutions. Obviously, it's a demonstration. If you couldn't tell, I'm not using my garage to park my car in currently because I'm taking all of the things that we're currently using, like bicycles and strollers and other things like that, to fill up my garage space instead of my car, since I'm not actually driving anywhere anyway. So I do normally park in my garage though. So the problem that we're trying to solve here is, when do you stop, right? When you pull into your car, into your garage, when do you actually park the car to give yourself enough room in the front to get around if you want to, on the sides obviously to open up the doors, and clearly in the back so that way the garage door can obviously close. So that's the problem that we're trying to solve. Now again, you can look at this in a number of different ways, right? You can also look at the problem being, I have too much stuff, right? Because if I got rid of some stuff, I'd be able to pull my car all the way in and wouldn't have to worry about that. Another way to look at it is, my garage is too small. So clearly, there are multiple ways to address that problem, since the number one step in the engineering design process is to define the actual problem. We're going to stick with that problem of, when do I park my car? When do I stop driving, essentially, in my garage? And where should my car be in my garage in order to have adequate space around it? So that's the fairly specific problem that we're trying to solve. And so we're going to step through the engineering design process, kind of show you some demonstrations of it, and let you hopefully solve this problem on your own. But you can also follow along with some of the things that we do as well. All right? You're right. It's way too nice to get started right now. So let's just enjoy this day a little bit more, and then we'll get to that design process and come up with some solutions. All right. So we're back down here in the makerspace. Not that nice of a day out today, so we'll get to work. And we are on the next portion of our engineering design process. We are about to start our brainstorming session. So when it comes to brainstorming, we want to make sure that we're coming up with any and every possible solution that we can think of, no matter how outrageous, how wild you might think it is. Write it down, sketch it out, think about whatever you possibly can. We will narrow it down later, so we'll go through and check to see if we have the materials, the budget, the criteria that we have to meet in order to make it successful or not. So go a little bit crazy with it. Stay focused, right? So one of the big things that we're going to have right now, myself included, is that there are a lot of distractions around the house. Maybe you can hear some in the background right now. Stay focused, right? Not only with what's going on in the background or with what's going on in the world, but also stay focused on the problem, right? You want to kind of encourage things that are going to be solving the actual problem that you're looking for. Again, we define the problem as, how far into the garage do we need to go? So stay focused on that particular problem. Don't start trying to build a bigger garage, for example. Another big thing is, don't judge yourself yet, right? So you're going to come up with these crazy ideas. Don't discourage yourself. Don't ever think like, okay, this is a silly idea, okay? All ideas are good ideas. All ideas are doable for right now. We'll talk about what makes the more realistic idea in the next step when we start planning out our process, okay? So let's get to it. I'm going to start sketching some things out and see what comes up. Okay, first idea. What if we had the car drive in and it just knocked something over? So very simple. You just made some sort of a stand. The car comes in. When you hit into that stand, obviously something you don't care too much about, something that's not that breakable or fragile, and then it just kind of knocks over or tilts in some way. Okay, idea number 2. What if you had the car drive in and there was a string or something stretched across the front of it, so that way when it hits it, it stretches that string out and it pulls some of those, whatever it's connected to on the sides, together. Either they fall or you can just see them shift in a way, therefore you know how to stop. All right, idea number 3. Along those same lines, what if you had a laser beam shooting at some sort of a target over here so that way when the car drives up, it blocks the beam, you can see on the target that there's no longer a beam of light there, and you know to stop. Idea number 4. Okay, what if you had a scale on the ground and you drove your car up, and when that scale reached a certain amount, you knew that your tires were where they were supposed to be, and therefore you're supposed to stop. Hey, here's the old ball on a string idea. That's when you know when to stop. Or you can have a bump, put it on the ground. That's when you know when to stop. What if you took an ultrasonic sensor, attached it to an Arduino, did some coding, and then had it turn on, say, an LED light, and that's how you knew how to stop? One option is to put a mark or something, have some reference point, and say, okay, when I'm next to that, that's when I should stop. The problem with that is that sometimes you have different drivers, and their point of reference is slightly different, right? All right, a little wobbly there, sorry about that. All right, so let's take a quick second just to talk about that brainstorming session that we had. A couple things I wanted to point out during that. First and foremost, again, do not judge your ideas, right? Anytime you judge an idea, you end up kind of discouraging any more ideas. So make sure that you're not judging too much. Some of them might have been silly, the one with the scale in particular, right? You might be looking at that like, come on, who's going to do that, right? I put that in there so that way, again, you would remember, don't judge, right? That might not be a legitimate option to put a scale in your garage, but you know what? It's an idea. Put it out there. It might be useful for something else in the future. Who knows? The other thing I wanted to point out too is that what I was doing as I was kind of demonstrating those was essentially a form of prototyping, right? So when I was taking like the block and having the car drive into it, that's your prototype right there, right? That's your first step to see like, will it work? You take a model and you see, will this actually work? If it works with the model, then scale it up and see if it works with the actual car. That helps too because not only are you saving time, money, and everything, but also you're realizing like if it doesn't work, more particularly, then you know, okay, don't even try it, right? If it's not going to work at this scale, it's not going to work at a larger scale, so don't even bother. Okay, so the next step after we start brainstorming is to decide which one of these ideas are we actually going to execute, which one are we going to take and actually make a prototype for, and that would be the one that we actually make a plan for. All right, so we're here, the plan, right? So we're going to decide how we're going to go about making a prototype for our solutions here. And again, the first solution that we're doing is or version I should say, of the tennis ball hanging down from a string, so when the car comes in, it knocks it and you know when to stop. So the materials, we're going to make a material list for it. Obviously you need string. I happen to have paracord on hand, which is always useful for a lot of things, so I'm going to use that. And instead of using a tennis ball, I'm going to use something else. So again, I don't want to give it away, but check that out. So it's a super simple thing. If you are doing something more complex, you really want to write this stuff down, plan it out in more detail. If you're working cooperatively, if you're working with groups, you want to make sure that you're saying, hey, this task is for you, here's your deadline. You're getting this material, here's your deadline. Make sure that you also set a budget during this time, right? So you have your plan. You have a sense of how much money you have. Go for that. And also get any kind of tools that you might need to make sure that they're together. There's all too often times, especially if you're working in a shop where a lot of people are at, you might rely on a tool and then realize it's not functioning at the time you go to get it. So just make sure that you have what you need. So in this case, the only thing I'm actually going to need, a pair of scissors. Check them out. They're working. Okay, we're good to go. Let's get started with our prototype build. All right, so we're in the garage. Kind of a windy day today, so we do have the garage door closed, but I'm here. I got my paracord measured and cut. I got my trusty helper holding the, right, Sebs? Holding the ladder steady for me.
Yeah.
And what we're going to do now is we're just going to, again, this is a prototype for now, so we're just going to test it out with some tape. So I got it measured, marked, taping it up here. Seb's going to leave that. And as I said earlier, instead of using a tennis ball in honor of this COVID crisis, we are using a roll of toilet paper. Okay.
Putting it on the pedal.
When are you going to stop the car?
When I hit that windshield.
Good. Okay, go slow. Go slow. Go.
Now I know when to stop.
All right, so we're back in action. We took the prototype, we put it through multiple tests, and it ended up failing, kind of as you would expect, partly because Elsa would continually not stop, and therefore our tape failed, which was kind of to be expected. Again, it was a prototype, right? So we did what we needed to do to kind of see if that particular solution would work, and then we tested it, right? So we did a number of tests, and as expected, it failed. So what we need to do now is kind of redesign, redesign, and hopefully improve. So we are right here, redesign and improve. And what we're going to do is essentially just make it a little bit stronger, so we can use something else to hold it in place as opposed to just the tape. I had a screw in mind, so we're going to give that a try, and we're going to also change the toilet paper out for a couple of reasons. Obviously, we're going to need that for more important things, but also because it didn't actually make sense, because in the long run, we realized that if you pull your car into the garage after a rainy day, then that rainy windshield that's wet is going to hit into that toilet paper, and over time, it's obviously going to cause some issues with the roll itself. So we needed something that was a little bit more durable, something that would last a little bit longer throughout the time. So we think we're going to stick with our original design using the tennis ball and go from there. So we went through the engineering design process, and what you might realize is that it's basically just a problem-solving method, and it's probably something that you've used many times in the past. All we did now is kind of formalize it. We put some labels on the different steps that you took. We might have spent a little bit more time in certain areas than were necessary, or than you may have done in the past, but basically it's a useful way for us to kind of collect our thoughts and to have a stepwise process as we go through solving some of these design challenges that we're going to be given. So we kind of left off with the design, redesign and improve. I'm not going to show you me screwing anything into the wall for a number of reasons, but you get the point as to what needs to be done for the engineering design process to be successful. And thanks very much for joining us. I hope that you had fun. Hope you learned some stuff. Hope you got a lot out of this. It was a pretty cool experience going through the engineering design challenge during these crazy times in my house with the random things that I had with 2 kids that I had to watch after. So I hope that you appreciate it. I hope that you, again, will join us for some more things as we go forward. Once again, my name is Todd Menadier. I'm with the Center for Math, Science, and Computer Education at Rutgers University. So check out some of our other videos. Hopefully you like them. Hopefully we'll see you again in the future. All right, take care. Driving.